So to answer this question, let's review what it means to be a function. So a function is a mathematical construct that simply just converts an x to a y. You can think of it as a little machine. So I can draw that here. So it can just be a little box here, right? There's f of x here. And that takes in an x and it outputs a y. And you can graph these. And this is actually a useful way to visualize functions, of course. And you've probably seen this. You can take an x and y axes like this. This is y, this is x, right? And a function can look something like, let's do a different color, can look like, something like this. Or it could look something like this. Or, it could look even something like this, right? So these are all functions here. Now, what's important to note is that for every x, there is one y that is given. For every x, there's one y. And that is the basic principle of functions. You can't plug in x and get out a different y each time. So I couldn't plug in, a 2 here. I couldn't plug in a 2 over here and get out either a 3 or a 5, right? That is not okay. It has to be 1x to 1y, right? So what this would look like on a graph, if we were to plot that, would be as follows. So if we have an x and y axes here, this is x, y. If functions were allowed to have more than one y value, what you would see, or for each x had more than one y value, what you would see is, for maybe an x of 2 here, you would see a y here of like 7 and a y here of like 14, right? And so what would this look like? Like maybe the function looks something like this. This is not possible. This is not allowed with functions. So to get to your actual question, let's come over here where I have the rest of the your actual tables here. So one way to approach it is to actually start graphing out the table here onto graph paper. So we can start by, taking each x and plot it to its y. So let's start with x equals 1. So x equals 1 here, y equals 2. So there's a dot right there. And x equals 2, y equals 7. So that's about here. And while I'm doing this, keep an eye out for anything that violates one of these, this kind of rule here, where a single x cannot equal more than one y. Okay? Now, x equals 3, y equals 8. So that's up here. And x equals 4, y equals 3. So we'll plot that about here. So if you look at this chart, we see that for every x, there's only, one y. So I think this checks out. I think this one, we'll give it a green check mark. This one is okay. It is a valid function. So let's look at the next one. And we'll start by plotting, just like we did up here. So we start with x equals 1, y equals 2. All right, much like the first one. So we plot that. And then we do x equals 1, y equals 7. So we do that, 1, and we come up here to 7. X equals 2, y equals 8. So we come up here to 8. And x equals 3, y equals 3. And so that's about here. Well, look at this. We've got an x that has both a 2 and a 7 for its values. So in this case, this would not be a function, because when you plug in x of 1, you're not sure which value it's going to output. It could be 2 or 7, which is not something that a function is allowed to do. So this one is not a function. Cool.